Harvey, we're on these notes. And we're going to fill out number 1 here for infinite limits.
Do you think he actually prints these out?
I have no idea.
I printed them out.
A limit. As x approaches a, where a is a real number.
Oh. Sorry. Just means it can't be I. That's all it really means.
True.
We're A and I.
So infinite limits means like your answer is infinity or negative infinity. That's what number 2 is talking about.
How many numbers is there?
2.
That's not running out of space.
The result is always negative infinity or infinity.
Hey, does count as real numbers?
No.
I don't know. What?
But this is just x approaches a. This is not talking about the answer.
Oh,
here.
I was like, since it has to be real numbers.
I did the same thing yesterday when I was rereading my notes. Indicating the existence of a vertical asymptote.
We've been doing this all year and we decided to go on.
Well, we're just about to compare it to limits at infinity, so that's why I'm, saying, hey, this one is.
Look, we've been doing this all year, but now we're going to
Yeah, but we haven't been doing the other kind. Ah! Okay.
Harvey enjoys these conversations. Yeah.
Okay, so the limit. Oh, I hope I'm not in the way. The limit as x approaches 2 from the left-hand side of f of the x. So let's look at this.
Some decimal.
There you go. As x approaches 2,
That'd be positive.
that is positive. Yeah, it's positive 2.
Oh, I was looking at negative.
Wait, from the left?
From the left, just
No,
kidding.
it'd be negative.
You were right, Win.
I was talking about from the right.
So from the left, it is going down forever. Now notice A is a real number. A is 2.
Yeah.
X approaches 2.
Why is it a real? What?
So that's negative infinity.
Oh, your backpack. I was like,
So limit as x approaches 2 from the right, Daniel.
Infinity.
Yeah, that one goes up there. That's at positive infinity. Y'all fill in the bottom 2. X approaches negative 1 from the left and the right for g of x.
Oh, okay. Oh, that's a different thing. I don't know what.
It's just a different graph.
Okay. That's a piece as well. From the left clip. Yeah. This made me learn my left and right. I still don't know it.
Just use the L thingy.
That's what I have to do.
That's what I do too.
I didn't know it. My left and right until like.
AP Cal. At least I taught you something.
Literally, when I read this, I think of positive and negative. That's what I think. I'm thinking which way, like the positive numbers, which is the negative numbers.
That works?
I don't even think left and right.
Okay, so Faith, what's limit as x approaches negative 1 from the left?
Negative infinity?
You are absolutely right.
Okay.
So as I approach negative 1 from the left, it's going down for forever.
You missed it as left and right again.
No, I thought we were still in that first graph.
Oh. And then, Stephen, what's the next one then? Infinity, because as I approach negative 1 from the right, it goes up forever. So that's positive infinity. Those are infinite limits because the limits equal either positive or negative infinity. Now the next side, we're talking about limits at infinity. A little bit different.
Just a little bit.
Just a little bit.
Just a wee bit.
It's a limit, and this time, x is going to be approaching either negative infinity or infinity. And the result is always a value or negative infinity or positive infinity, basically indicating the end behavior.
Oh, I haven't missed them. I don't know if I've missed them or not.
End behavior has to do with horizontal asymptotes or slant asymptotes.
Did we do end behavior last year? Yes. I don't remember. The only time I remember end behavior was algebra 2.
You remember it in algebra 2, but you don't remember it? Oh, God.
Yeah. Well, because algebra 2, I didn't understand it at all. And then I guess because I did it in algebra 2, I understood it last year.
That tends to happen a lot.
So that way I...
Just think, by the time y'all get to Cal 2, you'll understand Cal 1.
Yeah.
That's the way it works.
Or maybe I just don't take math next year. That is true. We can do that. I don't take math this year. That is also true.
Yeah.
So we don't really necessarily have to pass the class.
Don't break my heart, please.
We'll come back.
I'll cry.
We might not come back.
I don't even know what math. I mean, we only.
Okay, I'm moving on.
This year.
So the limit as x approaches infinity. So, and this is of f of x. So that means as I go to the right, because x is approaching infinity. So I'm going to the right forever and ever and ever.
2.
It's approaching what?
2.
2. It's approaching that horizontal asymptote.
How are we supposed to get to that diagonal?
We'll talk about it.
Positive infinity and negative infinity.
I don't know. I feel like it's some decimal.
No.
Limit as x approaches negative infinity. So as I go to the left
2.
forever and ever and ever, it is also approaching that horizontal asymptote, which is 2.
This could be some like equation.
You were right, Daniel, on the next ones. Limit as x approaches infinity for g of x. Get rid of these. There we go. So as x approaches infinity, so as I go to the right forever, notice slightly, but it is going up forever and ever and ever because there's a slant asymptote there.
It's a rebound.
So it is positive infinity.
The other one would be negative.
And the other one would be negative infinity.
Which is more.
Because as I go to the left forever and ever and ever, it's slightly, but it is going down forever and ever and ever. That's negative infinity.
I like how they drew a hole there to make us think that we're not. I hate the next one. We haven't got there yet.
Right? Okay, so unfortunately we won't always have a picture.
That's one of my bad. I'm not flipping it over.
Is it the wrong page?
No, it's 70.
Wait.
It's on a different page.
Wasn't it page 60?
We did it backwards. It's the next page. Yeah, you look, the next page right there.
Yeah, but
What is
it's
this?
60.
That one is day 8. They're backwards again.
Miss
This
King.
day 8, I don't like that.
I'm sorry, did y'all figure it out?
Yes.
Okay.
Yes. The page we're going to is like.
Alright, so here we go.
Yeah.
I'm sorry. Oh, we must develop analytical procedure. So we're going to figure this out so that we can do it without a graph. So it defines, if you do a limit at infinity, it talks about what the end behavior is. We've done end behavior before. It's just slept a little bit since then. So we're going to talk about these. So for the limit as x approaches infinity for this first one. think about what kind of.
Oh wait, is infinity because if the x is going to infinity? And
It's
y
like the.
Yeah, that thing.
Oh, I remember that from
Yeah.
the group.
So
Harvey-
it kind of looks like limits.
That hurt my feelings.
I told you, none of us remember doing this last year.
Okay,
I
maybe we didn't get to it.
No, we did.
We did.
Okay.
Okay.
I remember.
So here we go. So this is a cube. So that means it's an odd. The little 3 means it's an odd degree. And if it's an odd degree, then they point in opposite directions. And then you look at the leading coefficient, which is that -3, that's negative. So that means it's down, let me make sure, no, up.
Got him again.
Well, I'll still say down, on the right.
Honestly, up and down.
Okay. So the 3, the little 3,
Mm-hmm.
means that they're pointing, hi Harvey, means that they're pointing in opposite directions.
Yes.
And then because the -3 means that on the right, it's pointing down. So it's doing this.
Oh yes, it's negative.
So as x approaches infinity, so as I go to the right, what was the right side of this graph doing?
Down.
Going down.
No.